Hi everyone, it's Justin again. In the previous lesson, you learned that simplification plays a big part in what happens with irrational numbers, including most roots. In this video, we're going to dive a little deeper into how to simplify them. You already know what square roots are, the inverse of squaring. But how do they actually work? It's actually pretty simple. Let's use the square root of 49 as an example. The square root looks at the factors of the number. In this case, 49 is 7 times 7. And then for each pair of identical values, one of them is pulled out of the radical. For a better example as to how this works, let's look at the square root of 36. 36 is 2 times 18, which is 2 times 9, which is 3 times 3. We can visualize the next part by separating each pair of factors underneath their own radicals. The square root of a pair of 2's is a single 2, and the square root of 3 times 3 is a single 3. These two radicals were being multiplied, so after simplifying them, there should still be a multiplication here. And of course, 2 times 3 is 6. Now, should you have already known that the square root of 36 is 6? Sure, but this example helps you see how the square root factors and pulls out pairs to get its result. But what if we want the square root of a non-perfect number? They can be simplified, but they will always result in an irrational expression because, as we learned before, only roots of perfect squares are rational. In fact, the steps are the same as what we just saw. We factor inside the radical, then every pair of factors gets pulled out as a single number. Finally, we multiply the factors outside the radical and multiply any factors left inside. For example, if we want to find the square root of 216, first we need to factor it. 216 is divisible by 2, and so is 108, and again for 54. Then 27 is divisible by 3, which leaves 9, which is 3 times 3. So our factors include 3 2's and 3 3's. That means we can group a pair of 2's and a pair of 3's, which leaves a 2 and a 3 left over. The square root of 2 2's is just 2, and the same thing for a pair of 3's. The 2 and the 3 are not a pair, so they're going to stay under the radical. So we ended up with 2 times 3 times the square root of 2 times 3. The last step is to multiply the parts inside and outside the radical. 2 times 3 is 6, and inside the radical, 2 times 3 is 6 again. So the final simplified form is 6 times the square root of 6. Ready for another one? How about the square root of 810? First, let's factor. 810 is 2 times 5 times 3 times 3 times 3 times 3. So what pairs do we have? There's a pair of 3's and another, while the 2 and the 5 don't have pairs. 2 pairs of 3's means 2 3's get pulled out. Now we multiply. On the outside, 3 times 3 is 9, and on the inside, 2 times 5 is 10. So the square root of 810 is the same as 9 times the square root of 10. Type both expressions into a calculator if you don't believe me. They both come out to about 28.46. Even if we want to take higher roots, like a cube root, this process is essentially the same, with one small change. First, we still factor. 250 is even, so we know it's divisible by 2. 125 is clearly divisible by 5. And 25 is 5 times 5. So 250 factors into a 2 and 3 5's. For square roots, we pull out pairs of factors because squaring means 2 of a number are being multiplied. But cubing means 3 of a number are being multiplied. So to simplify cube roots, we have to pull out triplets. There's a triplet of 5's plus a 2 that's all by itself. The cube root of a triplet means that we pull that number out of the radical. So the simplified form here is 5 times the cube root of 2. So simplifying roots is as easy as factoring, grouping, and rewriting. But what if the root also includes unknown values? Well, in the next video, we're going to learn how to simplify roots that include variables. See you then.